All right. Good morning, everyone. I hope you can see and hear me. Otherwise, this is all pointless. Welcome to Summer 1, Boston University Elementary Physics 1 course. I'm Dr. Valentin Voroshilov, and I'm going to do my best to help you to master this course. And this slide is a reminder that there's a requirement. Every student taking this course has to use WebAssign. So if you have not done it yet, please try to do it now. I can see some people joined Zoom, thank you, and some people joined WebEx. You don't need to join WebEx for the class. In fact, you should not join right now. WebEx is for questions. When you have a question, in that case, you join. Computer makes a sound, I can hear it, and I can talk to you. Well, I'll talk about this later in more details. This is not an online course. This is a remote course. There's some difference. The remote course is designed in a way to be as similar as possible to a regular on-site course, with one twitch, one exception. There are no students in the room. So it gives me a slight weird feeling, but it's okay. Now, probably 5 minutes ago, everybody should have received an email. I just sent it. And I might do it again and again in the future due to different reasons. First of all, a student asked me on Piazza last night, what's the WebEx is for? Well, among many possible answers, one is I'm testing different technologies because, first of all, every technology might fail and I need a backup. Plus, I have to figure out the best approach for upcoming exam. And I have to test different options. So right now I'm testing two different options, Zoom and WebEx, and I might try something new. So please read those emails before the class and follow the instructions. And if you have followed the instructions, you should have answered this question already on the web assign, right? So the easiest way to communicate, if it's not urgent, is using the Piazza. Piazza is our course chat. And if you post a question on Piazza, an email comes to the whole class, and everybody can read it, including me and including teaching fellows, and someone will answer eventually. But if you want a rapid communication, you can use one of these. Or there's one more common option. You can call me. Oh, don't call from overseas, yeah, but if you're here in the US, you can call this number and we can talk. Меня зовут Валентин Викторович Ворошилов, и я закончил Пермский государственный университет по специальности теоретическая физика, потом защитил кандидатскую диссертацию в Московском университете. And I know that maybe only one or two students understood what I said and could read this. This is just an illustration of a simple fact. I am not a native English speaker, and in fact, I didn't learn English in school or university. I learned English when I was an adult from books, recordings, TV shows, radio shows. What does it mean for you? For you, it means sometimes you may not understand what I'm saying. I may have a heavy accent. I may sound in a weird way. I have to control the way I speak, and sometimes when I do that, I forget what I want to say about. And I might start speaking very slowly, like President Obama does, or very fast, making contradictory statements, like President Trump does. It doesn't matter. Appearances can be deceiving. You have to train yourself to ignore how I appear. It's not important. I'm here for you. Try to focus on the content, right? That's it. Plus, actually, I took a break from teaching in the spring, so I have not been talking English for almost a half a year. It's going to take some time for my neurons to get ready again to speak English. I know my name is complicated, even for me, when I write it. So I shrunk it to a very simple and memorable nickname. Mr. V, this is how for many years all my students addressed to me, and this is how you should address to me from now on, and from now on all my emails to you will be signed like this. So if you see Mr. V, it's me. And if you really, I don't know why, if you really hate that, you can choose some other option. Up to you. I've been teaching for a long time. Not just physics, also mathematics, like algebra, geometry, trigonometry, group theory, quantum mechanics, problem solving, logic, method for teaching physics, school administration. But lately, of course, mostly physics here at BU and other universities. And I am kind of good at that. At least some students say so. If you want to know more, you can find me online. Everyone is in Google right now. But I also have some feedback from the past. And you cannot read this slide, don't do it. Just an example. For every positive statement about me, there is an opposite negative, and for every negative statement about me, there is an opposite positive. These two I like the most. I'm going to read them out loud because the font is too small for you. So please do not join yet to WebEx. Again, the WebEx is not for lecture. The WebEx is when a question arises and you want to ask it, and in that case, you join WebEx. It makes a sound, and I go and I see, okay, someone wants to ask a question. Otherwise, it's just waiting for, well, any person. Plus, if you join late, again, very quickly, you can also call, or you can type your question on Piazza. I can see it. Here, how to send a Zoom message. There's a chat, and you should type your words there, and they should appear to everyone. The sound of Echo 360 should be done automatically, should work for you. Check settings on your computer, I would expect. All right, that might sound weird. Okay, I'm gonna unmute Zoom. So right now, if you cannot hear me through Echo 360, you should be able to hear me through Zoom, but still try to figure out what's happening to Echo 360. That's more important. And if you figure it out, and if Echo 360 starts working for you, mute. No, you cannot mute Zoom. Yeah. Well, let me know. I'm going to mute it here. But if you want to let me know something, in that case, I would prefer that you would use WebEx, because WebEx makes sound and calls me, so I could see someone wants to tell me something. Or, yeah, call this number. Well, the Zoom link has been sent in an email, well, actually several emails, so please check your emails from the last day. That's supposed to be there. For May 19, there was a different meeting scheduled. We had a meeting for testing Zoom on May 19th, and now, May 20th, there's a different meeting, should be with a different link. And I'm completely aware of the fact that first day might be the most hectic day of this course. That's why, on one hand, all right, someone figured it out. So I'm going to mute myself again. So on one hand, this is the most important lecture of the whole course because it lays out everything ahead of us. On the other hand, that's the least important lecture of the course because it's basically talking about general things, important, but not physics mostly, technical stuff, philosophy of science. All right. I'm going to go back to my slides. So, where was I? Here. This is what I wanted to read you. Yeah. You can tell he wants his students to understand and do well. Never felt like he cared for his students. There's a natural question. How could it happen that two people have been watching the same person for the same amount of time, listening to the same person, and in the end they came up with two completely opposite views about that person? In a regular course, I would point my finger at someone and I would ask, what do you think? Now I cannot do that, but I still want to ask someone, what do you think? How could it happen that two people came up with the absolutely opposite views? So again, these are the instruments you can try using. Well, I prefer WebEx. Someone wants to join. Let's give it a try. That's an experiment. Everything is experiment today. All right? Would you like to say something? Anyone? No? Type? Call? One student studied and the other student didn't. Good idea. What else? In physics, normally for every specific question there is one specific answer, but beyond physics, normally for every specific question, maybe many correct answers. Oh. All right, I'm listening. I'm going to mute myself here. So now again the sound to you. Hello. Go ahead, speak.
Maybe one. Sorry, I was just going to say maybe one student maybe sought out office hours while one didn't.
Well, could be, and that actually falls into a similar category. When a student works hard, that usually involves participating in office hours. I've lost sound again. Is there any way you could unmute yourself on Zoom? Well, this is a tough situation, because if I unmute myself for one student, many other students will have difficulties listening to two professors talking at the same time. So probably not. Sorry. Try to figure out it again. It's a situation when I have to make a difficult choice and I choose more students against one student. Well, I'm not going to spend more time on this. I've had many discussions and they all eventually came up to something like this. Steve Jobs said that. Of course, he didn't invent this statement, he stole it from another famous person, but in general, it kind of summarizes the idea. This is not the only PY105 elementary course available for students. Boston University, not Boston University, doesn't really matter. And it's a very well-known psychological fact that different learners, different students, learn differently. They have different learning styles, and different instructors, different teachers teach differently because they have different teaching style, and those styles might be a good match, good, but sometimes they might be perpendicular, bad match, it might irritate you. What do? Well, you always have a right to a divorce. I cannot leave, I have to stay, and I love staying, I love doing this. But you have a choice, and officially I have to inform you about this choice, and I don't want anybody to leave, I want everyone to stay. But if you feel it doesn't work for you, you have this choice, you have that opportunity. All right, this is another reminder that you should be logged in a WebAssign already, because right now I'm going to start asking more questions. The vast majority, probably 95% or so, of WebAssign questions would look like this for you. No answers, just numbers. So you will have to read possible answers, choose yours, and then enter it. Well, this is hard to read, so you can read it here, a larger font for you. And I planned on using Zoom today to break you into discussion rooms. I guess I'm going to stick to my plan and see what's going to happen. How many students participate? 57. So let's make 10 rooms. See what's going to happen. So right now, you can start talking to your fellow students. And I'm not going to hear you. I'm not going to join any room. I don't want to favor one room against another. So please feel free to talk. Now, I also want to see what's happening on a WebAssign. I like WebAssign because WebAssign collects and stores a lot of important information. Something is wrong. Okay, better. 145 students, and I want to see lecture 1. Let's check summary. So on the WebAssign, come on, okay. On the WebAssign, I can see who answered, what answered, more importantly, when answered, and sometimes even from where, based on the IP address. So it helps to analyze participation, effort, and lots of other things. Okay, that's a very natural distribution. Question number 2. 1, thank you. Question number 3. 1, thank you. Question number 4, also 1. Well, this is exactly what I hoped for. So it means the majority of the students is ready, technically ready to be technical. All right, so moving on. Now a more serious question. What do you think about physics? Some of you may have taken physics courses before, some may not. You may have heard something about it. So the question is, how would you finish this sentence? What single word would you use to describe physics? For me, it's a little bit hard to calculate how much time would I spend on a lecture. It's also an experiment because, first of all, what you see and what you hear is at least 5, maybe 7 seconds beyond what is actually happening here. There is a delay for you and then delay for me. So I have to deal with that. You have to deal with that. I have to keep in mind when I ask a question, it takes at least 5 seconds before you can see that question. So one word and one word only. I've asked this question many times, and I have a certain expectation about the distribution. This is not what I've expected so far. It's actually better than I've expected. From the past, the top 8. Well, yeah. In the past, the top 3 answers would be boring, fun, and complicated. And complicated is still winning, but in the past, boring was kind of had more weight in it. And that's true, because physics is boring for many people. Anything is boring for a person who has to do something doesn't want to do or forced into doing. That's natural. That's psychology. Did anybody say fun? Fun is 6. Some people said fun. And for those people, I want to say first, flattering doesn't work on me. Physics is not fun usually. It is fun for me and maybe for other physicists, yeah, by nature. But normally, boring wins over the fun. Complicated. That's wrong. The thing is, many people confused the meaning of such terms as complicated and hard or simple and easy. Simple and complicated. Do you want to ask a question? Not? Again, please only join WebEx if you have a question. Otherwise, just wait to the right time. So, simple and complicated. That's a description of the structure of something on a system. Complicated or complex means that a system has many, many elements, parts, but more importantly, many, many connections. That's what makes a system complex. But complex and hard, not the same thing. If you want to start a car, it's a very easy task. You just turn the key or press the button if you reach. And that easy action starts a very complicated process inside the car. So there is another myth that you cannot learn physics if you don't know mathematics. You don't have to know a lot, and everyone in this course knows sufficient mathematics, I can assure you. But to get the feeling of the difference between hard and easy, complicated and simple, try to walk on a rope and compare with solving a problem about walking on a rope. This is a very simple situation. Post, rope, walk. Simple. Is it easy? No. It requires a lot of practice. It requires a lot of effort. And physics is like that. It's simple. It has a very straightforward and clear structure and logic. Do you want to ask a question? Please ask a question. Well, some people have difficulties watching Echo 360. Technically, I cannot help you with that. Try to call IT right now and see what's going to happen. I hope the sound will be present in the recorded lecture. So I have right now, according to the WebAssign, one would expect something faster, right? 86 students who supposedly watching this lecture. And it looks like for 3 or 4 students, something doesn't work. But right now, you can talk to each other using Zoom. So please talk to each other, try to figure it out, help each other. Again, if I turn on the audio on any of these devices, in that case, all other students will suffer from that, and I cannot do that. Well, the only thing, if you really can figure out how to fix audio, you can call and stay on call. And now I'm just gonna to students who didn't hear me. Sorry for typos. All right, moving on. I like this analogy. Every healthy person, healthy brain, healthy eyes, healthy muscles, healthy bones can do this. That doesn't require practice. It's a naturally born ability to handle one ball. To handle two balls, one would need some practice, see? Some effort. But again, every healthy person can do that. The transition from 2 balls to 3 balls is a different story. But what's good about this course is a 2-ball course. Everyone can master it. Everyone can succeed in it. Because again, physics has a very straightforward logic. Down the road, in the end, you will have to solve some problems. And for every single problem in physics, there is a specific strategy. Everyone, Einstein, you, me, use the same strategy when we have to solve a problem. And this is a general strategy that has several steps, and some of those steps can be broken down into smaller steps. And this is the problem-solving strategy that works for any problem in physics. You cannot read this slide. The font is too small, and you don't need it because this is a copy from a syllabus. So my advice is to take a picture of it or print it out, copy by hand, and use it every time when you solving a homework problem. Get a habit of using this type of thinking, and you will be all set. One of my goals is to demonstrate how this strategy works. Now, physics is the second simplest subject to study. What is the first one? Mathematics. Mathematics also has a very straightforward logic and very clear structure. Some people may struggle with mathematics, but the reason for that is only they didn't have a good teacher, unfortunately. Physics involves a certain math knowledge, of course. However, the most important ability or skill to succeed in physics course is not mathematics, it's imagination. There are many reasons for that, and one of those reasons is physics is based on experiments, and we simply have no time and no equipment to do all important experiments, so we have to use our imagination to visualize what might be happening and how to understand that. And then, on top of that, mathematics comes, and then drawing skills, talking skills. Learning has stages, and the most fundamental stage is developing imagination, then learning how to read and write, etc., etc. Chemistry, biology, physics, science courses are somewhat there. They are based on a different background. Nowadays, we can find physics in many different areas: medicine, economics, even sports. That is why many people are forced into study physics. And I'm all for that. I think everyone has to learn elementary physics. Unfortunately, sometimes a teacher teaches physics as a combination of disconnected facts, and that makes learning hard. I try to demonstrate that physics has internal logic, and I believe that usually helps to master physics. Next question to you about you. This is the statement you want to refer to. I feel like I'm very good at physics. If you feel that way, select the answer number 1. If you have no confidence at all, choose one. And anything in between, yeah, depending on your feeling. All right, let's see. Resend. Again, based on the past, I have certain expectation about the distribution of your answers. And my expectation is 5 or 6 Yep. This is a standard distribution. Every year I see something like that. Some students choose 1, some 9, and everything in between, and the most popular answer is 5 or 6, which is absolutely natural, absolutely natural. What I want to say, if you think you're very good, perfect, but don't let yourself to be distracted or you may miss something important. If you have no confidence, well, first of all, physics is a science, and science cannot rely on feelings. Feelings tend to deceive us, and based on my experience, normally when people feel bad, they underestimate themselves. So try to boost your confidence, and you're going to be okay. And as I've mentioned, this course, as any science course, is based on a certain background. And everyone has that background, otherwise you would not be a university student. But people forget things, of course, that's natural. Some of that background might be missing. Don't worry, that's not a big issue. Every missing part of the background required to succeed can and has to be recovered. So the finish line is the same for everybody. Theoretically, everyone can get an A. But the starting point and the distance traveled may be different. It depends on the initial background, and some people may spend some extra time to recover certain parts. Of course, that would make the distance traveled to the final grade a little bit longer, but it's doable. Boston University is one of the top universities in the world. That's why Boston University faculty has certain expectations toward Boston University students. And the most important expectation is not mathematics or reading or writing. Is be active and organized. What does it mean? Well, it means if you have a question, raise your hand, ask a question. And if you right now are in WebEx already joined, if you type something, I should hear it, and I will read it, and I will say something, okay? Do not use Zoom to communicate with me. Zoom is not supposed to be for that. Zoom is supposed to be used for your own communication. Of course, right now, once in a while, I'm going to check on the Zoom as well, but I don't have to. Next, important information. Yeah. Well, you kind of know this, but it's important to process. The amount of the material for this course is exactly the same as the amount of material for any similar course. But in the fall, that material is stretched over 16 weeks, and now it's compressed into 6 weeks, right? So it's much more intense than it would have been in the fall. That's why being active and organized is very important. And it is hard to do or study science alone. So I suggest use Piazza, use Zoom, collaborate. Every university has two main missions. Number one, creating new knowledge. Number two, creating new people. And the employers, your future or current employers, they don't really care about this mission. They care more about that. Many surveys show that employers care less about specific technical skills and more about general soft skills like reasoning or communication skill. There is one more skill employers dearly care about. They may not say it out loud, but they really, really want it from everybody. And that skill is following instructions. Let me give you an example. When I sent my file, general instructions, at the top of the file, there was a note. It says, you need to send your waiver and honor code to a specific email. Do not send it to an instructor. And yet, dozens of people sent those waivers and honor codes to me. What does it say? Maybe those people didn't even read those instructions. Whether we like it or not, from the very first university that has been established more than 1,000 years ago, one of the functions of university is filtering. It's not something what faculty wants. It's not something what administration wants. You know, it's a built-in feature of every social system that has grading and ranking. It's inevitable. And these general skills are more important to get through than specific skills, because specific skills like math are easily recoverable. Okay, again, this is a remote course, so the structure is very similar to a standard course. We've got lectures, homework, exams. There's one twitch, labs and discussions put together in one longer investigative laboratory unit. So on one hand, it's longer, so some people hate it. On another hand, you don't have to sign twice, one time for lab, second time for discussion. Some people love it. You have all the information required for you to plan ahead. Just read the syllabus. Everything is in the syllabus. Now, if you have not made your mind yet about the waiver, you still have time. So please do it as soon as possible. If you do not sign the waiver, you have to watch these lectures live and participate in the WebAssign Live. If you sign a waiver, you have certain flexibility. You still can watch live lectures and participate, but you also can watch recorded lecture and participate in a WebAssign for recorded lectures. Lecture is designed in such a way so it should be fine, okay, for the majority of the people. Some of you may find material very simple, easy, even trivial. Good. Just, again, please don't let yourself to get distracted, or you may miss some important feature, something important. Some people may find certain material challenging. That's fine, that's natural. In that case, be active. Today, we will not learn physics, or at least of much of it. But starting tomorrow, we're going to learn more and more physics, and in that case, if you feel a confusion, if you have a question, you have, of course, an option to communicate with me that question. But also, I advise you strongly to write down in your notebook that very question. All right. So, unfortunately, Piazza doesn't make any sounds when you type a question, so it might be some time before you ask a question and I check the Piazza. That is why I, as an experiment, offer you using a WebEx for that, or a phone. And you don't have to write down every single word I'm saying, because first of all, it doesn't make any sense. Lectures are recorded, and all the notes after the lecture, not immediately, but during the day, will be converted into a PDF file and posted on Blackboard. So you will be able to check again every slide. But what you have to do is what I do when I start solving a problem. If I draw a picture, you have to draw your own picture. If I write an equation, you have to write your own equation. Listening and watching is not doing. It doesn't do much work in your brain. But if you do a gesture or say something, sing, talk to a friend, draw, write, every action excites more and more neurons in your brain. And that helps to build connections. And that's what is learning, building connections in the brain. That's it. So you need to, excuse me, yeah, first lecture after half a year of silence. So you need to help your brain to build those connections. I've said several times about the exams, no makeups, because the exams will be delivered electronically, and in such a situation there is no way to secure the content. So please make a mark, put it in a calendar, join at least 10 minutes beforehand to avoid any technical issues. And right now I am not sure yet what specific technology will be used, so we're going to keep testing technologies ahead. Labs, officially they begin today, but the first lab has been opened for you already, and many people are over with it. And the first actual lab takes place next week. I will send more detailed instructions later. I just wanted to show this. Even you're not here, I just wanted to show where you would have been walking if you would have to do the lab. There are different labs, rooms, and right now, this is meaning my lab room. I'm going to be streaming labs from this room. Homework will be delivered exclusively via internet. That's why you need a WebAssign account. And please, when you start a homework, and today you will see first actual homework assignments, read the description and the instructions at the top of it, because you will find some useful information regarding certain problems in that homework assignment. For each question inside each problem, for each part of each problem, you have 6 trials. But if you tried it 4 times and it still doesn't work, stop trying, seek help, send an email, go to Piazza, attend office hours. The WebAssign accepts your answer if your answer is within 4% margin from the correct answer. Normally, if your answer is a large number, if it's correct, it's automatically fine. You don't have to think about accuracy. But if your answer is a small number, a decimal 0 point something, in that case, keep at least 4 digits after the decimal point. Otherwise, your answer, even if everything is correct, might not be accurate enough. But again, decimals like these do not matter for a large number like this. 277, it's about 300. What is 4% of 300? 300 divided by 100, 3 times 4, 12, rounded up to 10. So the correct answer is at least 10 units away from it. Trying to fiddle with digits doesn't help. So this student just lost 2 submissions for nothing. Well, this is a history lesson. A while ago in the past, I used to set different deadlines for different components of the homework. But I always had emails from students, please extend my deadline, because eventually I just settled to one deadline for all parts of the homework. One deadline. I think it's 10 p.m. on a day before the exam, because it doesn't make any sense to do this homework after the exam. But I strongly advise do some homework problems every day. If you try to wait until the deadline and then solve all homework problems in one sitting, that's not going to work. You will fail. People tried and people failed. In order to graduate, you have to do at least 6 labs out of 7, doable. And also you have to have done at least a half of a homework. In 2007, in 13 years of teaching, that means 2,500, 3,000 students. 2 students failed this course because they didn't do enough homework. And following Bill Maher, I would say I don't know this as a fact, I just know it's true. I believe those students failed because they waited until the deadline and then they couldn't solve the required amount of homework problems. That's it. So try to spend, 2-3 hours a day, every other day on homework. Every time, every year, people ask me, how do I grade WebAssign questions? Well, the general answer is, I'm not going to tell you. That's a secret. Copyright technology. You don't need to know that. But I can give you some hints. As I said, WebAssign collects a lot of information. And that information can be analyzed in terms of accuracy, of course, correctness, but also in terms of effort. Let's say a student decided to answer all questions at the same time, despite the fact that different questions being asked at different time. Or let's say system finds out that a student answered questions that weren't even asked, because I don't have to ask all questions I planned to ask. I may skip them. So in that case, it's a clear sign, what officially called cheating, a violation of the honor code. And that's what system is looking for. System can figure out how much effort, even if the answer is wrong, but can, there are other parameters and variables, figure out how much effort is being put. And that's all I want to say about that. Please answer question number 12 after the lecture is over. This is an experiment. I've never done it before. I have no idea what's going to happen. Will you punish me? Will you reward me? I don't know. We'll see. Use as many office hours as possible. Today I have my office hours, well, not at 10, of course, because at 10 I have to leave this room. So about 10:15, 10:20, I will be available for you. And you can see many other hours available for you as well. Teaching fellow at the beginning of his or her shift will send an email. At the end, everybody gets the total grade calculated using this equation from a syllabus. And that number has to be converted into a letter. Yeah. That's the policy, which means somewhere here in this number line, someone has to draw boundaries between letter grades. Who? Well, officially, it's my job. And the syllabus represents you some examples of the boundaries. However, the syllabus also tells you these boundaries are not fixed. They might be shifted in any direction, and that has been done before, as you can see here. Why? Well, because the boundary is not set voluntarily. No. When the final grade is calculated, there is certain ranking. And you can see many students have a very similar grades, and the difference between the grades may be very, very small. But the boundary has to be stable against slight fluctuations in calculations, rounding errors, etc. So a boundary cannot be drawn between two very close grades. That's why there is an algorithm, a procedure, that searches for a big gap between two grades, and their boundary must be drawn. So when I do that, I just follow the procedure, the algorithm. It doesn't require any mental work except searching for the big gap. Because there are boundaries, there are students who are close to those boundaries. That's inevitable. An example of an email. Could you please round my grade? No. Rounding numbers would eliminate all decimals. That would eliminate ranking. That would eliminate gaps. That would make impossible to draw a boundary. Next question. Is there anything else to get some extra points? Well, this is how the final grade is calculated. It includes lectures, labs, homework, and exams. 1, 2, 3. There is nothing else, no extra credit, nothing. So the answer is no. A student writes, I feel, well, first of all, you know already, feeling is not a reliable measure in science. So it's not a good thing to start a letter from I feel. I put a clear effort when I read something like that. My first question is, does this student think that other students didn't put an effort? But more importantly, I can't just manually move somebody else's grade up. There is no such term as effort. Maybe it should have been, but it doesn't exist. It's not up to faculty level. It's up to policy level. And moving a grade for a single person would be simply unfair to everybody else. So again, the answer is no. Grading-wise, I have to act like a machine. Just follow the algorithm. And the best strategy to get the best grade is just not losing any points. Lectures, labs, and homework automatically give you a large portion of your total grade. And more importantly, if you really put your effort in lectures, labs, and homework, you are ready for the exams. Every exam is a set of problems. Not sure yet how many, but you will have to solve those problems live, and we will be watching you working. Not sure yet how, but we will. Me and 14 teaching fellows, and some extra screens probably. But the good thing about exam problems, they will be similar to some problems you've seen before if you have put some effort. Similar doesn't mean identical. Of course not. That is why it's important to be able to recognize those similarities. And to do that, the best case is following this strategy every time when you solve a problem. Plus, as you know, practice doesn't make perfect, because nothing is perfect, but practice makes progress. And you can use extra problems from WebAssign and from Blackboard to practice. Well, when lecture is done, your work begins. After the lecture, your main goal is to clarify everything that felt uneasy, unclear, and then practice with that. Understanding also has stages and evolves. Если я начну говорить по-русски, понятно, это бесполезно для вас. You have to understand words I'm saying. That's the first level, basic level of understanding. You need to understand sentences. Also, at the higher level of understanding, you need to understand reasons for my actions if I start writing or drawing or doing something. But when the lecture is done, your work begins. And Which slide on the fence? This? I'm not sure. I didn't say that word. But I said that, yeah, I said that if there is a boundary, there is always close to that boundary. That's what I said. That might mean on a fence. It probably was in one of the students' email somewhere here. That's what student wrote. I'm on the fence. So student thought correctly that his grade was close to another letter grade and asked me to boost it. And I said, that's impossible. Fence means close. So in order to get over the fence, the best strategy is do this. Practice. You're welcome. There is a saying, you can bring a horse to water, you cannot make it drink. In this analogy, water is that knowledge of physics, and you is this beautiful, strong, smart horse. But I cannot make you drink. I can only bring you to that ocean. All right, next phase of this general introduction. We're almost done. But as I said, no physics today. More important things to discuss. In 2 weeks, you will have to learn all this before the first exam. If you think that's a lot, and you are a pre-med student, think of all the names for the bones and muscles and chemicals and diseases you will have to memorize. This is nothing compared to that. So treat this as practicing your memory. Physics, of course, is science. Not every human practice is a science. And teaching is not science, for example. How do we differentiate what is science, what is not? I want you to use any of these means and tell me, what do you think is the mission? The mission of human practice we call science. The mission is that ultimate goal, the reason for the existence of that practice. And please, don't write thank you or I got it, because when I hear a sound, I think you asking a question. If you don't ask a question, please don't use WebEx. It distracts me. Okay, someone wants to say something about the mission of a science. Please say or type your opinion. If you type your opinion, your anything on Zoom, I also will see that. I will not be able to say something. I'm not a part of any room, but I will see that. So anyone, what is the mission of science? Maybe someone could call to test. Yes? If you want to join, please say something or type something. Otherwise, it doesn't make much sense, because the only reason we use this device is for you to communicate with me. If you do not want to communicate, oh, someone's calling. Hello?
Hi.
Hello, thank you for calling. Go ahead, say something.
Hi, I'm just answering the mission of science.
Listening?
So I think the mission of science is to know more information about the universe.
Thank you. Thank you, the unknown caller. That's exactly right. The mission of science, in one word, understanding. We want to understand the world around us and inside us. For that we collect knowledge, absolutely right. It's not a tricky question. And by the way, I almost never ask tricky questions. I do sometimes. So, there are many other important missions in the field of education. You cannot read this slide now, but if you're a curious person, you can read it when lectures will be posted. So, understanding. But how do we know that our understanding is correct? Sometimes something feels right, makes sense, but making sense is not necessarily correct. So I won't spend some time on this as well. Please tell me in any way, how do we know that our understanding of the world is correct? Please answer that question. Yes, if you think it's you, it's you. Yes?
Hi, I think that it's, like, the point is to have it.
Go ahead.
Hi, I think that it's just having something that's testable, like being able to prove it over and over.
And if it's testable, how do we use it?
How do we use it?
Yes.
Like,
How?
I mean, if it's testable, how do we use it?
Oop, I hear myself.
I'm sorry, I'm having like lag and it's asking it.
That's okay.
How do we use it? I'm sorry. I hear myself. That's okay.
I'm sorry. I got a mute. All right. You've been using two devices at the same time. That's smart. All right.
Yeah, I'm using the phone, and then I'm also have it on my computer, so I think it's like sending me a circle. I'm sorry.
Yeah, you have to choose one. Choose the phone, please. So I muted you. Yeah, so
I'm using the phone. I don't know why it's sending me circles.
it doesn't matter. It works. That's all that matters.
Okay. Sorry.
So when we think we know something, how do we use it? That's the most important question. And I have not much time left. So the last, please, if you join, say something. Okay, something. Just in an experiment, we can never really prove theories, but that's not how we use it. we use it to make our life better, right? We use it because in our life we have goals. Normally, we don't just wander around randomly. We have goals, and in order to achieve that goal, we design specific steps. And when we design those steps, basically, we make a prediction. If I will follow those steps, I will achieve that goal. So in one word, the mission of every specific science is making reliable predictions. And then we use those predictions for everything you said, absolutely right. And in physics, yeah, we have to make reliable predictions about some physical phenomena, in chemistry, chemical phenomena, etc., etc. And for that, I agree, we have to search for something that repeats itself. We call them patterns. And that regularity in space or in time is what we perceive, what we observe in the first place. Our brain is the most powerful pattern recognition machine. When we look around, we see things, and our brain makes from that chaos structure. And there are many different patterns. Some of those are visual, some of those are audio, and of course the most important patterns are numerical. This is, I know for you know, very famous sequence. It has a pattern, and if you figure out that pattern, you can make a prediction. That's how patterns work. You know that this is supposed to be 34, because the pattern is adding two numbers to get the next one. Of course, when we look around, when we make an observation, observation is not just staring. That's not enough. The result of an observation is a description. When we see an object, we say big, small, soft, hard. We name properties of that object. And something might be happening, we call it a process. Those processes might be fast or slow. They have properties. And if I start my scientific paper, today I was watching that thing, and that thing was doing another thing with that thing. Not very informative description. That is why every science has its own very developed language. And a part of learning science, actually a huge part of learning science, is learning that language. These are copies of the pages from the syllabus. This is the language we will learn in 6 weeks. Syllabus also has this page. I'm not going to read it. Go and read it. It shows intrinsic, important similarities between study physics and becoming a doctor. And one of these similarities, a lot of terminology. When we study science, observe patterns, we have to make a transition from a verbal description to numerical description. For that we need data. The more data, the better. And if we have data, I agree, we can analyze those data, find correlations, and those correlations tell us about some relationships, and then, if we're lucky, finally, only at the very end of this scientific process, we can write an equation. So before an equation happens, a lot of other work has to be done. So the mathematics only at the end of the reasoning process in science, not at the beginning like many people used to think. And that is why not everything is science. No data, no numerical patterns, no science. There is no science of education. Education is a scientific and practical field. There are people, scientists, who do science, but at this point, educational science is like alchemy, has certain rules, heuristics, and that's it. All right. How do we make a transition from verbal description to numbers? One word: measurement. We need to assign a number to a specific variable that describes a specific property of a specific object or a process. In physics, that process, measurement, is done by selecting first a specific object that's supposed to demonstrate the unit of that property. Well, I'm actually a little bit ahead. So right now, we are starting physics. All right. So measurement. Let's say we need to measure time. Time is a specific name, specific term. We call it a physical quantity, and that describes a property of being, existing, and changing, right? So if I want to measure time as a property of something, I need a process that repeats itself. So this could have been that process, because it repeats itself. And if it repeats itself consistently, I can say, okay, let's call the time required for this one motion to be 1. Well, 1 what? Well, I can say 1 Mississippi, 2 Mississippis, but historically people called it a second. And now I can calculate how many standards of time fit in a different time interval. Yeah? 1, 2, 3, 3 seconds. This is how every standard measurement works. We have a standard of physical property, and we need to count how many of those standards we fit in the property of another object. Of course, nowadays we have more accurate devices for measuring time, like atomic clock. And that word I said after a number, 1 second, 5 seconds, well, first of all, has a symbol that represents that word and has a general name, a unit. And different physical quantities have different units. Next one, length. Well, first we need to establish a standard of length. So we have a long ruler, cut it up, and we say, let's call it 1. Cannot call it 1 second? No. Second is taken by time. So we need to figure out a new name. Let's call it a meter. All right, done. What do we do next? If I want to measure length, all I have to do now to count how many times can I fit this standard in the length of this object. 3. Well, almost 3. If I want to be more accurate, what can I do? I can break it down into smaller parts, decimeters, centimeters, millimeters, and then I can count how many of those I can fit. And of course, nowadays we have more accurate standard. And the last most important standard for us now is the standard of mass. Let's call this one standard of mass. Well, we need to invent a unit for that. Can we call it a second? No. Can we call it a meter? No. So let's call it a kilogram. All right. What do we do now? Now we need to figure out how to compare the mass of other objects with the mass of this one. I feel, oh, sorry, feeling is wrong in physics. We need a device. And of course, such a device has been invented for us, like this one. No, not equal. Ooh. Good enough. Now we don't rely on feelings. Now we rely on measurements. And of course, nowadays, again, we have many other devices. They've been calibrated. We can just use this device to measure the mass of anything. All right, my alarm says I have 1 more minute left. I'm just going to finish this lecture. Thank you, everybody, for watching, listening, and participating. And in about 15 to 20 minutes, I will begin my office hours. I will send an announcement, an email about that. Stay healthy. Bye. Goodbye, everybody. Oops, close. Yeah. Hello. Yes, on Blackboard. Everything is on Blackboard. Good. Yeah. I wish you would ask this question before I would be able to answer to the whole class. But anyway, yes. If you log into the Blackboard and go to folder course documents, you should find office hours schedule there. No, it's a separate file. I will check it later, but it's supposed to be there. The Blackboard was recently updated, and sometimes it still has some strange issues. If it's not there, I will post it there, and I will